This question is a graph question. Um, a quadratic graph is involved, as you'll see. Before I start the question, that graph to the left is the diagram after all the work that's been done. I'll just show you how I get there step by step. So your first task is to copy and complete the table of values. Of course, you'll have read given below is an incomplete table of values for y equals x times 4 minus x, right? 4 minus x in brackets. So to complete the table of values, you'll realize that two values are missing. Two y values are missing. So for each of those x values, you have to work out the matching missing y value. So the first missing y value is an x value of 1. Okay? So the first, as I was saying, missing y value as a matching x value of 1, so as of negative 1 actually. So here we go, this is part A, I'm squeezing up here. So when x is equal to negative 1, y is equal to negative 1 times 4, take away negative 1. Work that out, you see that is 5. Negative 5 actually, right? That's a negative 5 right there. So you're going to have a negative 5 in your table of value. Okay? And then the next missing y value is where x is 1. So when x is equal to 1, y is equal to 1 times 4 minus 1. And of course, if you don't realize by now, the x's I'm just substituting in the function, right? The given function y equals x, open bracket 4 minus x. I'm just replacing the x there and work it out for the matching y's. So there we have the second y value, 3. So that's part A, right? Now part B says, using a scale of 2 centimeter to 1 unit on each axis, draw the graph of your function, right? The function is y equal x, open bracket 4 minus x, close brackets. So here it is over there. Now the points are in the table of values. So if you look at the graph to the side now, these dots are the points plotted. So you plot each point. It's a total of 1, 2, 3, 4, 5, 6, 7 points. And then you're going to join them with a smooth line. Do not use a ruler for the graph of a quadratic. So you're going to join the dots with a straight, with a nice curve, right? Like that. It doesn't have to be exactly nice, of course, because you're not a computer, and you'll have the graph. So here it is. This is the graph of the function y equals 4x minus x squared. It should be equal there. And then draw the tangent to the curve at x equals 1. Now the tangent is a line that just brushes the curve or just touches the curve at 1 point. So it's not going, if it intersects the curve at 2 points, you lose that point. Not everyone is going to draw the same tangent, of course, because again, you're not computers, but the tangent line should look something like this. No, they want it to be tangent on the graph when x is 1. So x is 1 right here. Of course, x is 1, so that's 1 on the x-axis. X is 1 right here. So this is the point on the graph where x is 1. So you're going to use your ruler and draw a tangent like that. What you can do is if I can just find my ruler here, is rest your ruler on it. And let me get my tools. Right, what you can do to get the tangent is take your pencil and stick it at the point, and then you rest your ruler on the pencil, right? And then you draw that line. Draw it as long as you can, but ensure that it does not intersect your curve twice. That's just touch it at one spot. If it intersects twice, then that doesn't qualify for a tangent, okay? So that's a tangent line in red drawn here, tangent at x equals 1. So that's part C1. And then it says use the tangent to find the gradient of the curve at the point x equals 1. Now this you may not know, but on a parabola, as you can look at this, it has different steepness everywhere. So every point on this graph, the gradient is different. It's not like a straight line where the gradient is just the same thing, m. Every point the gradient is different, and the gradient at each point is equal to the gradient of the tangent. So the gradient at any point on the parabola is equal to the gradient of the tangent at that point. So when they say use the tangent to find the gradient of the curve at the point x equals 1, you just need to find the gradient of this curve, right? And remember, gradient is what? Rise over run. So what you need to do, find 2 points, find 2 clear points right, or two closely clear points, like this point here, I'm going to use the tangent point or the point of tangency as one point. And here's another point here that I'm going to use, right? So I'm going to check the rise over run from one point to the next on that straight line, and that's my gradient. So the rise, that looks like 2 units, right? And the run is 1 unit, so the gradient is actually 2, right? So the rise over run is 2 over 1. And this might look like 4, but remember the scaling was 2 centimeters represents 1 unit. So it's 2, 1, 2, that's the rise over 1, that's the run. Rise over run. So the gradient there is 2 over 1, and that you get from the rise over run. Okay, just make those little points in the graph to show that you know what you're doing. And then they say use the graph to, and by the way, you can read this question in the past paper booklet. It's 2004, number 12, paper 3. All right. The last task is use your graph to solve the equation x open bracket 4 minus x close bracket is equal to -1. Now here's something new for you at this time. If you want to use a graph to solve, or if you want to use graph to solve an equation, you need to draw the graph of y equals the left-hand side and the graph of y equals the right-hand side. But if you look at this, we already have the graph of y equals this side, right? X open bracket 4 minus x. We already have this graph. We already have the graph of y equals x open bracket 4 minus x, which is the parabola, of course, the blue line. But we do not have the graph y equals -1, but everybody should know to draw the graph y equals -1. Actually here, this is if you didn't recognize it. This is the graph, this pink line. This is the graph y equals -1. As you can see, it's the horizontal line through -1 on the y-axis. So that's why it's called y equals -1, this pink line. Now, how do we use it to solve? Wherever the two lines meet, which will be here, wherever the lines meet, which will be here and here, you read off the corresponding x value for the answer. So, of course, to read off the x value, you have to track it up to the x-axis. That's one right there. And they have another meeting point here, point of intersection. So you track it up to the x-axis and read off those values, and those are going to be your answer. So for part D, I'm going to just write it on a graph here. For part D, I'm going to estimate this to be a quarter, right? X equals 0.25, negative of course, negative 0.25. And this over here, I'm going to estimate this to be 4.25, this point right here on X equals 4.25. Notice I said estimate because usually when you draw a graph, you'll be very lucky if you end up on the exact point. So when you're reading values of graphs, if it's on the exact point, then you'll have to give an estimate for those, right? So to use a graph to solve, I'll say that x is -0.25 and x is 4.25. So again, let me repeat this. If you're to use graph to solve an equation, you need y equals each side, right? So I have y equals the left-hand side. So I have to make y equals the right-hand side now, which is y equals -1. I have those two graphs. Wherever they meet, I trace it up to the x-axis and take off the x value of where they meet, and those will be the solutions. All right, so you can go through this question. Whatever you don't understand, just ask me in class, okay?